He has published over 11 books on JavaScript, taught thousands of developers from teams around the world, and has training videos that have been watched for over 800,000 hours. He is always fighting for the people behind the pixels. Let's welcome to the stage Kyle Simpson.
Thank you, Jason. Appreciate that. And in the position of being the closing in-person keynote, I guess, Jason had us all clap for the speakers, which, by the way, some of the most fantastic talks I've seen in a long time. Those are great. But I also think that we need to give a round of applause for all the staff, Sean and Leo and all the others that have made this work, and Jason. So let's give a round of applause to them. It's been a fantastic. I also want to take a brief moment because I'm in this position, and right before I came out, Jason was like, take as long as you want. So I'm like, okay, cool, I'm gonna just take no, I'm kidding. But I do want to take a moment of silence for what's happening in the world right now, because it super sucks, and I don't have any statement that I can make on how we're supposed to process this, but the tragedy, especially for families and kids, is breaking my heart. And so I just want us to take a moment to think about that, think about the responsibility that we have to the rest of the world. All right, so my talk is imperative versus declarative, weathering the storm. And I'm sure most of you, when you heard that title or you read that title in the booklet, the burning question in your mind was, why on earth is this not just a medium think piece, right? Like, why do we need a whole conference talk about something that seems so dry and uninteresting, perhaps, as imperative coding versus declarative coding? Now, listen, I'm biased, of course, but I think this might be one of the most important talks, and I'm really glad that it was positioned in the way that it was, because I hope that you will view the things that I have to share with you today through the lens of the stuff that you've heard from our other fantastic speakers. It's not in any way to suggest that one is right and one is wrong, but I want this to provide a lens for you to view those choices that are being made by the other technologies that we've looked at. So the first assertion that I will make, and I'm a bit of a broken record on this topic for anybody that's heard me for a while, is that code is really for humans, not for computers. And that sounds like maybe it's a trite statement, but I really deeply believe this, almost at a religious level, that the most important thing that we're doing when we're hands on keyboard, fingers on keyboard, is we are communicating our ideas, our thoughts, our plans, our structures to other human beings, including, by the way, our future selves. It is a happy side effect, in my opinion, that the computer can somehow figure out how to do something useful with the stuff that I type on the keyboard occasionally. So if we really are about trying to communicate with other people, and it's in a written form, then we really ought to be spending more time thinking about the readability, and we ought to be optimizing for that. And I think, sadly, we're not nearly optimizing enough for it. I'm going to make another statement, which is probably going to feel a lot more controversial to you, but I'll say that code must first be read before it can be written. It's counterintuitive, perhaps, but I really believe this to be true. Number one, I believe our brains kind of go through this sort of reading phase as we visualize and formulate the ideas that we're about to type out. If what we're typing is hard to read in our brains in that pre-scan phase, then it's a pretty good chance that it will come out flawed. That represents most of the code I write, I think. Number two, most of us are copying, pasting, and editing code, either from Stack Overflow, if you're old school like me, or from ChatGPT for the hipsters out there. But we have to be able to read that code before we can paste it in and write our code on top of it. And number three, most of the code that we're writing is not greenfield. It's not in some empty file. It is being added to, amended to, modifying existing code. And it's usually somebody else or one of our past selves that wrote that code. So any code that passes through any of those phases of that process, it is being read first before it is being written. You know, studies say that we spend 70% of our non-meeting at keyboard time reading code. And yet we seem to spend so much more of our time in this industry optimizing how easy and how quickly we can write code, doing more with fewer lines of code. I think we should be optimizing for the thing that we spend the most time on, which is reading code. I'll also say that if you have written some code, you are not the person who should be judging the readability of that code. And I know that might sting a little bit, but I'll just say that you'll tend to feel a natural emotional affinity for any code that you just wrote. If the test passes, of course, otherwise it's going to be anger. But if there's this familiarity with that code, it will skew your judgment. You'll forgive your own code much more than someone else's. And inevitably, you are thinking about way more context. I call this like a mental bubble floating around your head. You're thinking about way more mental context about the code that you wrote down than the actual code that you put into the file. That is all floating in your head. And when you read that code back, all that mental context is still alive and well, and it hasn't yet been garbage collected. But the problem is that none of that mental context exists for other people that read that code. So they have to reconstruct it only from what you've typed into the file. And most of the time, that is harder for others than it is for ourselves. Of course, if you wait long enough, your future self will have forgotten. Some of us, this is a few months. Some of this is a few weeks. For me, it's a few days. I'll forget exactly what I was thinking when I wrote a piece of code. And so you can come back later and judge that code based on its readability. But it's far more important for you to involve other people in this decision-making, rather than saying, I really enjoyed writing that code, therefore it must be readable. That doesn't count. That's not readability. Just because you got a clever piece of code to pass the test, that doesn't count as readability. All right, it's time to clear up some definitions, because there's a whole bunch of words that we like to throw around in our industry. Most of the time, we don't really have a precise understanding of what we mean by those words. So first off, the most obvious, what's imperative and what's declarative? And I'll make this really easy for you. I'm going to answer these two questions on this slide. No, yes. And if you're not getting that, that's a little pun from the Who's On First comedy bit. What's not imperative? What is declarative? In other words, imperative code, this is not unique to me, many people have said this, but imperative code focuses more on how do we accomplish some task, whereas the declarative code focuses more on what are we trying to accomplish, and maybe more importantly than that even, why we're trying to accomplish it. If you can look at a piece of code and the what and the why can come through without being distracted as much by the how, then it tends to be more declarative in style. And there are some obvious reasons why programmers, why developers would prefer to understand code without having to be a mental JavaScript engine executing things to figure it out, to infer the what and the why. It should be a bit more obvious. Another way of saying it is that imperative code is really focused on the instructions, and in particular, things like flow control, decision-making, conditionality. Whereas declarative code is characterized by non-conditional, and it's characterized by intent. If the intent of the code is more obvious, then it tends to be more in the declarative quadrant rather than the imperative quadrant. Yet another way of defining these two words is to point out that imperative code tends to be very explicit, whereas declarative code tends to be very implicit. Now, I don't know about you, but I actually kind of get these backwards in my head, so I always have to rearrange because the IMP and imperative and the IMP and implicit, seems like those ought to match up. They don't, so now I just remember their opposites. Imperative is explicit, declarative is implicit. When we say implicit, what we mean is that the code that you're looking at does not show all the details, that some of those details have been, here's another word that we need to define, abstracted. Abstraction, this word that we throw on everything. It's like you put salt on everything in your food, you just throw abstraction on everything, and it seems to solve all of our tech debates, right? We need a new abstraction. So what exactly is an abstraction? Most people would tend to define an abstraction as being about hiding implementation details. If I were to poll the audience here, I would guess most of you would probably lean in that direction. That's not what abstraction is about. Abstraction is actually about separating concerns, not about hiding things that you should never go and look at, but rather separating things so that you can separately reason about each independent of the other. And more importantly even than that, it's about creating a mental model that maps from one of those domains to the other and back. if I can understand how to accomplish a task and separately reason about that, and then elsewhere in the code I can reason about what I'm doing with that task and why I need to perform that task, and I can create some mapping, some naming convention between the two, then I've established a good abstraction. That's what it's about. So stop thinking that abstractions are about hiding away the code that nobody wants to look at. You absolutely should be going and looking at the implementation details. But you should be able to do so without being wrapped up too much in the greater domain, the what and the why. Let me illustrate this notion of it being on a spectrum. And I'm going to start with everybody's favorite tool these days, ChatGPT. So here I said, I'm 43 years old. Please write a first-person voice sentence stating how old I am. And it came back and it said, I am 43 years old. Now, I believe, allegedly, that natural language generative AI is near the pinnacle of what we consider a declarative interface. We just said what we wanted, and it figured out what that meant and how to say it back to me. It's not quite the Star Trek Enterprise computer, but it's getting pretty close. And even in this simple example, however, we already see a bit of leaky abstraction. And a bit more on that, so keep that in mind. So when we look at it on the surface, this looks pretty declarative. Now I'm going to show you some JavaScript equivalent of that code. Pretty straightforward. Declare a variable and console log it. Now, I would like to assert that this code is more imperative than the ChatGPT equivalent because it is giving a precise instruction to the JavaScript engine. This is how to construct the string. This is what should be in there. This is what should be interpolated into the string. And it should be sent to the console log. So this is more imperative code than the ChatGPT equivalent. However, if I show you now the C version of that code, now all of a sudden, doesn't the JavaScript start to look a lot more declarative than the C version of the code? It's a little bit more subjective. It's a bit more of a spectrum. From where you stand, the same piece of code might be judged as imperative or declarative, depending on that perspective. And I'm going to go even further, and I'm going to show you, and just as a little caveat, this is ChatGPT wrote this code. Please don't run it, because I don't know what's going to do to your machine. Been a long time since I wrote assembly code. This is the assembly language version of it. Now the C programming looks positively declarative, right? From this perspective. So it is a spectrum that we're dealing with. It is all about your perspective, and I would like to ask you to think long and hard about which perspective should we be most concerned with in this case. And I'll suggest to you, it's the reader of the code, not the author of the code. So declarativity, it establishes a grammar, and we could substitute in for that word grammar a mechanism, a vocabulary, a model. It establishes something for us to describe our intended outcomes. It's almost like an API. It is saying, I want to have this outcome, and I'm giving you a way to tell me that that's the outcome I want. And honestly, it's quite a lot about naming things, which I know that we're historically bad at. But it's also about organizing. It's about separating some things and combining others. All of that flows into the mechanisms that we describe our intended outcome. Let me give you an example. Print amount x plus y. Straightforward code, and in some perspectives, this is the pinnacle of how that code could be written. For example, if you're a functional programmer, you love the idea that this expression is inline. It's not taking up any extra space in my mind or in the program. It just is computed and flows directly into the place that it's being used. Compared to this version of the code, where I first compute and assign that computation to a variable that I call total here. Now, I think most people probably would tend to think that the first one is a little better because it's shorter, it's more terse, it does not involve a variable. But I'm going to suggest to you that the second version of this, by our definition, is more declarative because we have stated the intent of that computation. We have said, why are we adding x plus y? Something that's missing from the first version of the snippet, and we have added additional intent declaration to our code. Now, functional programmers are going to hate declaring extra variables, but I'm telling you, if you want to make your code more readable, this is a critical skill, deciding where those lines need to be drawn. And I cannot prescriptively tell you, you have to put everything in a variable. But I can tell you, if you're putting nothing in a variable, you're missing out on the opportunity to name things and give more intent to your code. Let's keep going with that example, though, because the same way that I could have computed total here, x plus y, using that plus operator, I instead could have defined some function that I'll call add two nums here that does the plus operation for us, and then in computing down here on the last line, when I compute my total, I just call that function. And again, if you're a functional programmer, you're like, great, we want as many of these utility functions, these pure functions that do work for us. We give it a little bit of an interesting name. You know, functional programmers would probably name that like ink or something like that. But add two nums here is some sort of descriptive name for that operation. And it might seem that from what I said on the previous slide that we certainly have moved in more declarative terms and that that's better. But I'm not quite so sure that that's true. There's some subjectivity here. Is the name add two nums actually adding anything useful to the reader of this code on top of being able to see the plus operator? Is that really helping them? Now, some computations, absolutely a name would be helpful, but in this particular case, I think it's a bit of a gray area. And what I'm trying to indicate to you and push you to understand is that there is no hard and fixed, yes, it's declarative, yes, it's imperative, yes, it's good, yes, it's bad. There isn't any of that. We have to take our own thoughts into account. We have to own this process. So, declarativity is not an absolute. It's just not. It's highly subjective. It is on a spectrum. Let me go back to that ChatGPT example from a bit ago. I mentioned that it had a bit of a leaky abstraction. This was not my first attempt at using ChatGPT to get my desired outcome. My first attempt looked like this. I said, I'm 43, tell me how old I am, right? And it kind of got close to what I was hoping, but not quite. And so you know what I did? I had to pull out my prompt engineering skills. That's a whole job now. I had to pull out my prompt engineering skills and force it to do something. I had to tell it, oh, I'm really looking for something in the first-person voice, right? I had to give some implementation detail to the system. So one of the things that I'm illustrating here is that any declarative system, no matter how good it is going to require some affordances. First of all, good design of declarativity does need to resist leaking unnecessary implementation detail. It should resist that. Good design should not require us to have to understand, right? Treat things a bit more like a black box. I shouldn't have to boil the whole ocean of understanding all the way down to how the electrons work just to get something to run on a computer. But that is not to say that you shouldn't have any knowledge of or access to those details. You absolutely should. And as the advice I always give folks is, you should master whatever level of abstraction you work at, but you should also be competent at the level below it. You don't have to be turtles all the way down and become an expert on electrical engineering. But whatever level you choose to work at, if it's frameworks, then be great at frameworks and be competent at JavaScript. If it's JavaScript, be great at JavaScript and be competent at the C-level languages below it. But also, good design of declarativity admits the need for imperativity to refine the outcomes. And this is the real rub, because every system that aims to be declarative eventually has to add in these affordances. And the question is, are those systems designed well so that those affordances go with the grain? Or do those affordances end up watering down and eliminating all the benefit of the declarative system in the first place? That's the real rub. We need those, but will we just monkey patch them on later? I think we've had a lot more of that of late. Okay, so it is going to require discipline. Just like in TypeScript, where the easy thing might be to just use the any type, but we know that discipline says, no, you really should make sure you're very clear about your types. You can still get the TypeScript to compile if you use an any, but everybody knows that's not the best. And so if you have a declarative system that can properly express what you're trying to accomplish, you should use the declarative system. You should not just fall back to what is easy just because that's what you've always done. Use the tools that you've been provided to you. And it's going to require balance. I know this is super cliche, but in all things, moderation and balance, especially here. A good program deftly balances this tricky, teetering jumble of code ideas. I've been designing a programming language lately called FOI, whose goal is to perhaps strike a maybe better balance between functional programming declarative idioms and familiar imperative techniques than maybe some of the other languages, many of whom have tried to do that before. And I just wanted to quote briefly from my language's mission statement. The right thing should be intuitive, the risky thing should be apparent, and the problematic thing should be difficult or impossible. And I would like to suggest perhaps that more of our systems should try to adopt that spirit. All right, some examples. Keep in mind that our grammar, our framework for how we judge things on the spectrum of imperativity and declarativity, right? Is it adding information that is helpful to us? Remember that imperativity is characterized by flow control, by decision-making, by conditionality. So where we see that, we see the needle moving back along the spectrum towards imperativity. SQL, or SQL, depending on how you like to pronounce it. Textbook-wise, this is the declarative language of the textbook examples, right? This is a declarative language. I'm not telling the database engine how to go get all my results or where they're at or how to do any of the form. I'm just saying, this is the results I want, go get it. It's kind of like the GraphQL, but older, right? So SQL is supposedly declarative, but you'll notice straight up, I've got a case statement right there in the middle because I needed to do some decision making and formatting and substituting a default value in this particular case. You can also think about the order of the fields, like in the where clause or the order clause. It's maybe not so obvious, but you can affect the behavior of your database, the performance of it, simply by choosing to list the fields in a different order and whether an index is going to get chosen or not. So there's leakiness in this abstraction, even in one of our most vaunted examples of declarative coding. And I'm not saying that they shouldn't have that, but I'm saying that we should be using that lens to ask, are our declarative systems being written such that they allow these affordances without completely eliminating all the value of the system in the first place? Do they plan for those things? It is important to note that declarativity does not mean there can't be any conditionality or flow control. It definitely always is. It just shouldn't be right smacking you in the face. That's the real question. All right, so HTML is surely the king of declarativity, right? It's just markup. It's just giving some semantic structure to some data. There's no conditionality at all. There's no imperativity at all, except there is. Here again, we see the imperativity, the conditionality creeping into what is otherwise a declarative language. The alt and the placeholder attributes provide content that is only shown in certain cases in response to device and user behaviors. And literally the nesting of the fallback content inside of the canvas or even the no script, those actually look like if statements if you squint at them, right? Because we're asking the HTML to do some decision making for us. Is this a good form of imperative affordance on a declarative language? I am much better at asking these questions than answering them, if you haven't noticed by now. All right, so let's switch gears a little bit into some more complicated stuff or some more capable things. This is HTMX. I have not written HTMX, so I only grabbed this example off of their website. To my untrained eye, I know there are Angular experts here, so I'm afraid to say this, but to my untrained eye, it looks a little bit like Angular. You know, they're using, like HX instead of NG, but it looks a little bit like Angular. They're just adding these attributes, and something is coming along in the background and saying, I know what to do with that. I'm going to kick in and cause these behaviors to occur. So most of the examples that I found on the HTMX website look pretty reasonable, if I'm being honest. But there are some affordances that start to fall in, and we break out of the declarative when we tweak things. So, for example, if you need to handle something that they don't already have a tag for, you drop into an entirely different language than JavaScript called Hyperscript. I guess it's a lot like JavaScript, but it has a different name. Hyperscript, and you just stick that code directly inside of attributes, string values on attributes. I mean, I'll just be honest with you. I don't know HTMX. I'm not saying anything good or bad about it, but personally, that's not high on my list. I guess you could say, wait for it. I'm not a big fan. Okay. I'm going to keep moving on. JSX. Now, I understand the attraction to JSX, and I understand, as some of our other speakers have pointed out, that we don't have to do quite so much context switching, except we kind of are still doing context switching because we start with what looks like an HTML tag, and then we immediately break back into what is just JavaScript. We put some curly braces around it, but we're putting JavaScript directly inside of it. Sometimes we do that pretty well, and I would say this is probably an example of a fairly straightforward usage of a this is the null coalescing operator, but it's a little bit like a ternary operator. There's a conditional decision happening here. But this is an affordance, for sure. And the questions that we should be asking ourselves is this watering down too much? It just depends, because one-liners like this, not so much. But I've seen a lot of code bases where we're putting lots and lots of JavaScript and function calls and other types of control conditionals inside of those little curly braces. And I've got a second example here, which is going to point out a different problem, perhaps, with JSX. This is pulled from an app that I'm going to talk about in a minute that I've started to build. It's the usage of this nesting of what are non-UI elements. And this is very characteristic in frameworks like React, I guess, where you're doing these providers and other sorts of things. And if you're not paying close attention, you might not have realized that that is really just nested function calls. That's function composition. But we chose to model function composition in JSX form because it's already the abstraction that we're using for the presentational elements. So why not just keep going that way? And while it works, I'm not sure that that's the best declarative form. We have lots of prior art on how to define function composition, both imperatively, like we see at the top, but we have multiple different ways that are time-tested and accepted ways of doing declarative function composition. If you're a functional programmer, you love things like compose and partial application. Or if you're a JavaScripter, of course, we always have to invent our own little bastardized version of it. So we have the pipeline operator, this famed thing that is maybe someday coming to JavaScript, where we can just do the pipeline of expressions. The point is that both of those, and even the top one, I think, are expressing something very important, which is that this is function composition. That is not an unimportant detail. That's a very important detail because it might affect the way that I choose to nest things. So, we have to be careful that we don't over-abstract. Now I'm going to talk about CSS, and we have CSS masters here in the room, so I'm going to feel really bad because they're going to tear apart my code. But CSS, declarative, right? We just say we want all the paragraph text to be read or something. There's a tremendous amount of conditionality that's come into modern CSS. And I'm not in any way, shape, or form saying that that conditionality is bad or that we shouldn't have added those features, but through the same lens, we should be asking ourselves, is this conditionality, is this flow control helping us, or should we be lifting that conditionality out to some other layer and describing it there? That's a question that I don't think we're asking enough. I certainly don't hear those conversations being asked enough. Everywhere we look, we start off with something that is, in theory, beautifully declarative, and then imperativity always seems to creep in. And sometimes it works pretty well, and sometimes it really sucks. Luckily, we have experts like Leah Veru, who are on the working group, fantastically smart, and they're on the task, right? They're helping guide. So I don't have any qualms about the future of CSS. But now I'm going to show you another set of CSS, and this is code that I actually wrote, and I super don't love, but I wrote it. So I wanted to render a horizontal bar chart using only HTML and CSS. And you'll notice that there's a little bit of conditionality implied in here because the bars are either rightward facing or leftward facing, or to use the logical properties, startward and endward facing, I guess, in the inline direction. And I needed to do some things. So I am using conditionality, but it's hidden in the form of math. Right? So CSS has an absolute value function, but it doesn't have very good, great browser support. So I'm using a little trick up there on the value sign custom property, is that I'm dividing a value, I'm doing the dividing of the value, value ABS, that's the one I was trying to talk about. Value ABS is taking the max of the value and the value multiplied by -1. Either way, I'm going to get the absolute value out. Then I use that in value sign, that's what I was starting to talk about. Value sign divides the value by its absolute value. So I either get a positive 1 or a negative 1. And I'm going to use that in some math tricks in a moment. But notice I had the little max in there because I had to make sure that I wasn't doing a divide by 0, right? So I'm using CSS's capabilities that are provided to me. I'm not super proud of it, but I was able to express some conditionality, like deciding which direction the bars are pointing or where I put the rounding or where I move things, just like I did with bar translate x and the left rounding and right rounding. See there, I was basically saying, only do left rounding when I'm pointing in this direction, otherwise bottom out to the 0 px, and only do right rounding for the other bars. And that's where the conditionality is happening. Now, this is math, okay? So math, I guess we would generally say, is pretty declarative, and this is using CSS declarative capabilities, to our advantage. But is this the right place for that? Should I have lifted this out instead to the JavaScript layer, which is, I guess, the more common place that people do that. They make decisions and conditionally apply a class or something like that. So I could have pulled that out, but we could have pulled that out of the SQL, and we could have pulled it out of the HTML, and yet we don't do it in those places because we prefer to leave as much declarative as we can. All right, I'm going to get flamed a bit for this one. When I talk about JavaScript and everybody's favorite villain, the double equals operator, okay? Now, all 4 of these are essentially identical in outcome behavior. They're not strictly so because the middle 2 are a tiny, tiny bit slower than the first and the last, but it doesn't matter what the performance is. I want to ask you, on a given line of code that may do a comparison like this, if you're certain that that x variable will only ever have a number or string because you're probably using TypeScript, then is it actually important for the reader of this code to think about, to contend with, the notion that the value of 3-ness could be represented as a number or a string? Is that important information for them on that line of code? Or is it that for this reader on that line of code, unimportant implementation detail? Because that's what the double equals operator is doing. It's saying, don't worry about that whole type thing. I've got it in this case. Let me handle it there. So counterintuitively, I'm going to suggest to you that the double equals is the more declarative of all these 4 options, because it's the implicit one that says, let JavaScript handle the type issue, because that's not important to the reader of the code at this line of code. I know it's fun to hate on the double equals and to follow our linter rules and say that triple equals is the only way to do it, but using this declarative imperative lens, sometimes we end up with counterintuitive results. Some more JavaScript examples. We know about the switch statement or if-else blocks. You may have seen that people suggest that we should just stick these things in objects and then use a property lookup on that object to invoke the action. So the bottom version is supposedly more readable and more declarative. I actually think that this is a digression because it's really starting to take away from the question, which is, what happens when there's nothing there, when there's not a matching one? It's much more clear that I'm missing a default action here, but it's very sneaky that I'm hiding under this question mark dot parentheses operator, which is one of my most hated features of JavaScript, but I'm hiding away that default case when it doesn't have any function to call. Yeah, it's a bit more imperative, it's hidden some detail, but I actually think we've lost important information when we go that direction. One more JavaScript example here. You've probably seen code that looks like the top, where you're setting up a variable and setting up a loop and having some if conditionals. What it's doing is not terribly that important, but the point is that we can recognize that code, and probably many of us have written code like that. That is the more traditional imperative form. Of course, we have on the bottom the more functional programming approach, which uses the filter and the map approach, and that is traditionally said to be more declarative. And again, more declarative is usually better under the lens that we're using for this talk. There are lots of developers, though, that are intimidated or less in favor of those functional programming techniques, because filter and map only mean something if you've already been indoctrinated into that way of thinking. And if you haven't yet, they're not necessarily going to jump out and make themselves super obvious. The point I want to make here is that the imperative version of this code is not worse. It's not bad. We shouldn't look down on it. We shouldn't say you're a bad developer because the top version of that code is something that you feel better about. Readability is highly subjective, and we need to all inject a whole lot more empathy into the way that we structure our code. we need to be asking ourselves, what am I expecting and demanding of the readers of my code? All right, I'm going to give you a brief moment just to stare at this cute kitten, because that was a lot of code, and I usually don't like to put so much code. So it's a cute kitten that's eating a dessert, just to give yourselves like a visual and mental break for a moment. I don't like to put code in my slides very often. This is a departure for me. Okay, the last example that I want to talk about, we've been talking about contrived toy examples for a while, and I want to look at a real app code for just a moment, and I'm using air quotes, and they're doing a lot of work there, because it's code that I wrote and I'm super embarrassed about. Most of you who follow me for a while know that I'm kind of the anti-framework guy. But I recently set about to learn React. I'd read about it a whole bunch, but I'd never really put my fingers on the keyboard and tried to write a React app. And I wanted to do so mostly for the purposes of learning, but the side benefit is that it provided some good material for the talk. And I think we could say that one of the core tenets of React, and broadly all of component architecture that we've talked about at this conference, is that we have this benefit of declarative UI. I think we'd all agree that that's one of the main selling points. And it's supposed to make our UI better if we express it declaratively instead of building it up imperatively. You know, the old jQuery style that we did before. Okay, but declarative UI is only part of the story. What about declarative UX? That's the real issue here. React is famed for being good at declarative UI, but how does it fare when expressing declarative UX? For example, when I click on a button to fire off an asynchronous action, what immediately happens is feedback. Do I see some sort of spinner or other indicator that confirms to me that the system heard my click and it's working on a response? And more directly, if it's going to show me a spinner, does it show it right away? Even if the response comes back so quick that it would have caused only the briefest of flickers, where it shows the spinner and then hides it almost immediately. Or on the other side of the coin, if the operation is taking long enough that I am seeing the spinner actually go on for a bit, do I have some way as a user of changing my mind and saying, actually, no, let me cancel that. I don't want to do that. I don't want to wait. Can I do that? And maybe more importantly, should I be able to do that? Declarative UX for any of these nuanced UXs? I think not so much, at least as far as I can tell. You know, I'm a noob here. But if I wanted any of that UX, I think I'm stuck maybe having to wire all of that up imperatively, or, and in my particular perspective, worse, just go find some other library that does it for me. Because what I was trying to do was do it only with what I had out of the box. I actually used another framework on top of React called Redwood.js. It bundles in React, and it handles stuff like the Vite bundler and dev server and all that stuff. It's like a better version of Create React app that still actually works. But they do a bunch of really cool stuff with GraphQL and things. None of that was relevant to my use case, but I liked Redwood because I was able to get up and going without having to learn the whole tooling ecosystem around React. So when you're ready to eye roll at these next couple of slides that I show you of my terrible React code, please just remember I'm a total React noob. I do want you to ask yourself, is React not actually all that concerned with its lack of handling of declarative UX? Is that why there's this huge ecosystem of every library you can think of on top of React? Because you're not really meant to declaratively express the UX with just React. Now, I know React is just a rendering layer. It's not a framework, right? Does that mean it only draws static pixels but leaves all the other UX up to other tools? And really, what does that mean for the imperative versus declarative question of all those other tools? Should that fully alone count as a capable declarative user interface if it's just the pixels? I didn't want to learn all those other tools. That seemed too overwhelming to me. So I wanted to build only what I could, all the UI, UX, and state management, all of it, but only with what I got out of the box with React. Is that a good way of going about it? It would seem maybe not. But at least I can say it was absolutely intentional about that. Okay, enough ado. So this is the app that I built, and I'll pause while you bask in the amazing design skills that I'm showing off here. Yeah, I'm not a designer, and I clearly know I'm not getting a Webby award for this. But at least it's not just the black and white HTML text that my personal websites had for 20 years. I did try to design something, maybe. Anyway, I want to look at how I built it. First, how did I divide up this UI into its components? Well, I had a search component, and then I had a location component, and then I had a weather component, which also included my little configuration component that's hidden by default up there. It rendering-wise made sense to go there, and because the configurations change how the weather comes back, conceptually it makes sense there, but like visually it makes no sense for those two to be in the same component. Anyway, let's look at some code. Here's my homepage component, and you'll see that I'm using hooks. Certainly one of React's most controversial decisions. Some people love them, some people hate them. Honestly, I would not claim to have designed this code this way. This code emerged from me just fiddling around trying to get it to work. This is not how I would have set out to describe declaratively what I wanted to get done. It's emergent code. The location stuff here, right? You'll notice that I've got a couple of properties in an object, and I'm sticking them in a state slot, which immediately should probably be a little like red flag, like what's going on here. It's not super obvious, but in some cases, I need to be able to change one of those and cause a re-render cycle, like when the user clicks a cancel button. And in other cases, I need to reset those back to their defaults and not re-render. Well, how do I do that declaratively? How do I have the same state slot sometimes cause a re-render and sometimes not, when both times I needed to change its value? I don't know, maybe there's some super cute or awesome answer to that question, but I couldn't figure it out. I spent some time Googling and Stack Overflowing, and I couldn't figure it out. So I did find somebody talking about hacking it by putting an object there. If I change the properties of that object by reference, it doesn't cause a re-render. But if I stick a new object in the state slot, immediately it re-renders. Okay, that's not, in my opinion, a great example of declarative interface design. It's super not obvious from the code, but that's what's going on down here, is that I'm resetting those without causing it to go back through another re-render loop. Really, the hack that I'm doing this is because I put out on my LinkedIn, I was like, hey, where do I put all of my business logic? You know, all the stuff like fetching the weather results and location API and packaging up the data. Where do I put all that stuff? I'm like, I've written it out in a, nice clean ES module. Okay, where do I put that into my React? And half of the people said, oh, you got to go get XYZ state management library or whatever. And the other half of the people were like, use a custom component. So that's what I did. So I've got this use get location custom component, and that's where I stuck all my stuff. The problem is that a custom hook does not have an API that I can directly call and say, cancel what you're doing. I have to cause a re-render loop and send in some data that says the user wants you to cancel the pending request. So the whole re-render thing is not because I actually want anything user interface to happen, maybe. It's really just so that it's the only way for me to communicate into my custom hook that's holding all of that work that's going on. So that decision had a profound effect on the whole rest of the app. And I would say that it watered down a lot of the declarative value that I might have been able to get out of this system, because that's the only way I knew how to do it with what I had out of the box. How exactly do I signal into that custom hook, right? By the way, signals, they're awesome, but they are not the silver bullet here. I could do a whole talk on the implications of the imperative versus declarative nature of signals. So they're awesome, but they're not fixing this problem. We have to own this problem. So after I had done the cancellation and needed to reset it, I'm going to move on because I think you probably get the point. Again, this is not code that I'm proud of, go do it like this. It's what emerged from me trying to express what I thought was a pretty simple app with pretty simple user experience. All right, so here's one of my JSX components, my search component. Cool. Except look at all the mixing of concerns that are going on here. Leakiness of abstraction, to say the least. The search component, who's a sibling of the location component, still needs to know something about the state of its sibling, the location component, and even to be able to affect that state to clear out one of the boxes. And it also needs to be able to control another sibling, the weather component, and its state. Cancel it. So I have to pass all this stuff in. I have to, hold it out in the parent and then pass it all into each of these siblings. What's more, the search component cannot even properly fully encapsulate something as obvious as its own search input element, because there are other interactions in those things that might need to clear that box out, and I don't have a way to tell all of those things, to have all those things signal over to say, clear it out, so I have to lift an external forwarded reference of the search input. That's what's going on there, forward ref or whatever. Again, I just Stack Overflowed until I figured that out. The declarative component nesting does not seem to offer any compelling answer for how we properly coordinate the interaction between siblings. And this is a mess of abstraction spaghetti. Last slide of code, I promise. What does it say about the power of React's declarative abstractions if it seems so difficult? I'm a brand new React learner, but I think you could say that I'm pretty decent at JavaScript. If it was so hard for me to figure out reasonable ways to express declaratively my outcomes without resorting to all these imperative hacks and abstraction leaks. Is it a strength of the React ecosystem that it's left so much to be solved by other libraries? Or is that a hint that maybe the abstractions that it exposed are a little lacking? What's absolutely clear to me is that the declarative abstractions alone are not sufficient here. They help, they're not enough. Okay, so just to be clear, I know that big chunks of that code that I wrote suck. That's why I showed you my own code, so I can dunk on it. It's obviously still quite a bit of work in progress. I plan to keep iterating on it, maybe rewrite it in some other frameworks, and of course in vanilla JavaScript, maybe like a to-do MVC style thing. If you really want to tear apart that code I used to make it, you can find it deployed on this URL, it's live, and in the footer of the site has a link to the code. I'm happy to receive all constructive feedback. I'm sure you'll have lots to say about how I should have done it differently or whatever. I'm ready for it, bring it on. But at least now all of you understand the reference in the talk's title to weathering the storm. So in my final thoughts, I think that it's clear that the choices we make on how we design and employ our abstractions in our code will deeply affect the readability and understandability of our code. Unfortunately, I think we probably outsource far too much of that thinking to the designers of these tools, the libraries, the frameworks, even the linters, instead of owning more of that direct responsibility for those choices. It's not enough to just use some pattern or tool that everyone claims is declarative. They claim it's well extracted. They claim that it produces readable code. It's not enough. We have to take active steps to analyze what we're building and ask those questions and own that code. You really need to be more intentional with your teams about knowing why you're doing the things you're doing, instead of just largely being dictated to you by the people who created those tools. Demand more and better abstractions from those tools. If they don't give you that, find tools that will. You know, honestly, that's sort of a weak summary of the takeaways of this talk. I wish I had some great final slide to give you. But honestly, I think I'm asking you, the audience, what will the big takeaways of this message be? I don't think I'm going to know for a while. Not until I see what, if any, impact this talk has on the bigger discussions that we're having as a community and broader industry. You have way more influence over what this talk's ultimate message is than I do. Are the questions that I pose going to make any difference? Perhaps some part of this talk made you a bit uncomfortable or frustrated or mad. Will any of you walk out of here still pondering what the actual point was? Will you go back and debate any of those questions with your teams at work? Will that ever change how you approach a single line of code? And I think the thing I'm most interested in, will I, sitting out there in the audience in some near future, get to see one of you up here sharing some important new insights into any of these questions? I don't know yet, but I guess we'll see. Thank you very much. I just want to point out as I'm here that I have this hashtag, I need a job. I really do need a job because I unceremoniously was terminated last week. So if any of you liked anything that you heard in this talk, please come up and talk to me about that. But thank you very much for listening. Jason, where's my Jack Daniels? I thought we were going to have alcohol out here.
Oh, man, I really did drop the ball on that.
I was promised.
All right, so we need to make sure that we get the crew who's been working really hard for these last few days, make sure we get them out on time. So we're going to do a slightly abbreviated Q&A, but we've got some really solid questions in here. First and foremost, a good question is, there was an assumption, or I guess an implication in the talk, that conditionality is imperative. Is that what you're saying, and if so, why?
I'm asserting it, but it's also on Wikipedia, so I'm going to just say Wikipedia defines imperative code as being characterized by conditionality, flow control, decision making.
Got it. And so does that, like, I know you weren't saying don't ever write imperative code, but so is the message here to minimize it, to, like, I guess, in a perfect world, how are you balancing this? Right?
Yeah.
Because obviously we need conditions to make code do things.
The program can't get away with not making decisions. Otherwise it's not a useful program, right? You do have to have it. I guess the real thing that I'm trying to drive home here is that at every line of code, you cannot simply outsource, this is declarative because I'm using a declarative system. You have to ask, is this affordance that I'm taking advantage of here to do this decision making helping my code, Or is it hurting and watering down the benefit that I'm supposed to be getting from that declarativity? Some of the systems that I showed here had pretty decent representation for those affordances. I would say CSS is a pretty good example of having some pretty reasonable ways of doing conditionality without completely destroying what we know is the essence of CSS. Others of those systems, I think not so much. It feels like they just bolted it on at the end. So we should be asking that and demanding more of our systems.
Got it. So I would say looking at some of what you were building up there and some of the ways you were talking about it, some of the solutions to things that you were talking about not like passing around the functions or things like that, seems like it might be solved with reactive programming. So in your mind, do you consider reactive programming to be interchangeable or comparable with declarative programming?
So I get a whole nother hour to answer that question, right? Just because no.
Maybe Cliff's Notes.
Yeah, no. So first of all, I'm a fan of reactivity, and as I mentioned in the talk, I think signals are great. I've been doing versions of that for more than a decade, and I'm a fan of it, and I'm glad that that is starting to permeate more. I do not think that reactivity is this silver bullet of declarative, that signals are the silver bullet of declarative reactivity. There are lots of devil is in the details with this stuff, and we need to be a lot more cautious about saying, well, because all these other frameworks did it, we just got to throw this in. So I'm not saying that reactivity is bad, but it is very much a slippery slope where you get into very quickly jQuery-style looking code, which is what I think most of us were trying to get away from. Mm-hmm. But we just slide right back down that hill because we're trying to model everything with reactivity, and I don't think everything should be modeled that way either.
Gotcha. So in cases where imperative escape hatches are needed, which I think is going to be any program, are you following any rules or best practices about how you design those when it's your code?
I honestly am, and maybe part of this is because I speak and teach a lot, but I honestly go through a bit of a role-playing anytime I write a piece of code, which is, it's kind of like the rubber ducking style, but I specifically will pretend in my mind and run through a role-playing in my mind that I need to teach this to somebody who's never seen any part of this app before. And I run through what would that be like if I was trying to make a little mini workshop to describe why I structured and architected it this way. How would I describe it? And what I'm really trying to do is figure out what questions are they going to ask me. What WTFs are they going to throw at me? And that's when I know this isn't done yet. I got to keep refining this stuff. So I would encourage that sort of rubber ducking style, and maybe just literally going and grabbing another person and saying, would you look at this for a minute and just tell me what is the first 2 questions that come to your mind? And you don't even have to respond to them. Just take those questions, go back to your desk and say, I got to work on this, because that's not quite obvious yet.
Got it. All right. So I'm going to ask you a final question here. Okay. And it's from Jessica, so I'm sorry.
Of course, yes.
Early in your talk, you mentioned prompt engineering.
Uh-huh.
So would you say that engineers who work quickly have prompt engineering skills?
Thank you, Jessica. Well, they do seem to be able to get a lot done quickly, but they sure have a lot of failing tests.
All right, y'all. I think we're going to call that a great stopping point. Kyle, thank you so much for spending some time with us. This was wonderful.
Thank you.